Good morning, students. In the previous class, we were discussing about the different types of the data types in C++, isn't it? What are the different types of data types in C++? They are, that is, the fundamental data types, derived data types, and the user-defined data types. All that the discussion is completed. Now, about the fundamental data types we had started. So what are the different types of fundamental data types? They are, the first one is int, correct? Then the second one is the float type. Then the third one, it is the double, correct? Then the fourth one, it is the char, C-H-A-R, char. And the fifth one, it is the void. So these are the 5 different types of fundamental data types. Out of these 5 fundamental data types, we had discussed the int type and the float type. So what is int type? Int is the data type which is used to represent the integer values, correct? They are used to represent the integer values, correct? That is both positive and negative. Both positive and negative integers are represented by using the integer data type. And they consume 2 bytes of space in the computer memory. 2 bytes of space in the computer memory. Correct? Then the possible operations on the integer data types are, what are the possible operations on the integer data types? They are addition, subtraction, multiplication, division, and modulo division. So these are the 5 different operations that can be performed on the integer data type. An important question for 2 marks. Okay. So what are the explain the int data type, or in general explain the fundamental data types in C++ also. Okay. So integer values can be represented by using the int data type. They will represent both positive and negative numbers. 2 bytes of space will be consumed in the memory. Addition, subtraction, multiplication, division, and modulo division are the possible operations on the int data type. Clear? Then the second one is the float. That is the floating point data types. We also call as floating point. Floating point. What do you mean by floating point data type? Is they are used to represent fractions. What do you mean by this? The numbers with the decimal point, for example 25.25. The numbers with the decimal points can be represented by using the float data type. They also can be used to represent both positive and negative numbers. They also can be used to represent both positive and negative numbers. Clear? Then the possible operations are addition. Subtraction, multiplication, and division. Because we cannot find out the remainders of the float type. Why? Because we are not going to remove the point there, not like a normal division. When you divide in the normal way, mathematical way, you will remove the point and all, no? So that we are not going to do here. Only the integer division we have to do. That is why the remainder cannot be found. These are the possible operations on the float data type. And it consumes, that is the float data type, it consumes 4 bytes of memory. 4 bytes of memory. Clear? So this is about the intent float data type. Third one is the double. Third one is the double. What do you mean by double? Is nothing but it is the double precision double precision of float type. Float type. Double precision of float type. What do you mean by double precision of float type? Float consumes how much? 4 bytes of memory. Here the double, which is the double precision of float, means it consumes double to that of the computer memory of the float type. Clear? So it consumes, instead of 4 bytes, it consumes 8 bytes. So this is the meaning of double precision. Okay? That is, it consumes 8 bytes of memory. It consumes 8 bytes in the computer memory. Clear? Then the possible operations, exactly remaining functionality of the float and double, they are one and the same. So the possible operations are addition, multiplication, subtraction and division. They are also used to represent the fractions. See, they are also used to represent the fractions. So this is about the double. Next one is the char, C-H-A-R, char we call it as. That is, it is used to represent the characters. Okay, characters means if you have to represent any text, alphabets, group of characters, then we have to use the data type as char. Okay, so used to represent characters. Used to represent the characters. Clear? If you have to represent single character constants, that is, if you have to represent single characters, okay, then we have to write it within the single quotes. Within the single quotes we have to write. Single quotes means what? Like this. That we have discussed already. So they are used to represent the character constants. Then if we have to write the single characters, those single characters have to be written within the single quotes. Clear? It consumes how much? It consumes 1 byte of space in the computer memory. So it consumes 1 byte of space in the computer memory. Clear? Then the possible operations are with With a character data type, what are the possible operations? You only can tell. What? We can either input the data or we can take the output. Correct? So the possible operations are input and output. So this is about the character, that is the char data type. So they are used to represent the characters. Single characters, if you are writing, you have to write that within the single quotes. Then it consumes 1 byte of space in the computer memory. The different possible operations that can be done on the char data type are input and output. Clear? Then the last one. The last one is fifth one. It is the void. Fifth one is the void. So if we have to represent the integers we use int, if we have to represent the fractions or decimals, we have to use float. If we have to represent the characters, we use the char. Then what else is remaining? That is, if the function is not going to return anything back to the main, in that case, we have to use the data type as void. Clear? We have to write it as void. So, when the function is not returning any value, when the function is not returning any value, in that case the data type that we have to use as the void. So void is used as a return type. We call it as a return type. That is, we have to write void. After the void, we can write anything. Clear? So this is the void data type. When the function is not returning anything back, in that case, we have to represent it as void. So this is about the fundamental data types. Different types of the fundamental data types. It is a very, very important question, either for 2 marks or for 3 marks. Clear? Yes. Next, one small definition we have. It is called as a modifier. Modifiers. What do you mean by modifiers? Is they are used to alter the meaning of base data type, so that it more precisely suits the requirement, so that it more precisely suits the requirement. What do you mean by this? It is used to alter the base data type, meaning of the base data type. What do you mean by this is, we know that int, base data type means fundamental data type, okay? So int is the fundamental data type, we know. Suppose when you are writing any number, when you have to input any integer value, you know that int data type, it consumes 2 bytes of space, isn't it? Int consumes 2 bytes of space in the memory. Suppose if you are writing a quite bigger number and this 2 bytes is not sufficient. Clear what I told? You are inputting a quite bigger number, and if you think that the 2 bytes whatever it is allocated, if it is not sufficient, in that case we can convert this int, that is instead of the int we can take long. Basically its function is same as int only. Okay, so if int is not sufficient we can go for long. When we use the data type as long modifier, long is the modifier. Okay, when we take the modifier as long, in that case the available space is 4 bytes. So you can input quite a bigger number also. Suppose you have taken it as int and int is more than the requirement. You do not want that much. In that case, we can take it as short. Then short will be half of the int. Long is double of the int. Long is double of the int. And short is half of the int. Short is half of the int. So these two are the modifiers. These two are the modifiers. Clear? Like this only, we have the other modifier as we have discussed this already. The unsigned, that is the numbers without the sign and sign, that is to represent the number with sign. These two are also the modifiers. This much is enough about the modifiers. So the modifiers are the data types that are used to alter the meaning of the base data type, so that it more precisely suits the user's requirement. So if you have int, if you think int is not sufficient, you can go for long. If you think int is more than the requirement, then you can take it as short. Similarly, signed and unsigned. So this is about the modifiers. Hope it is clear. So this is an important question for 1 mark. Okay. Yes. Till now we have discussed a very important concepts of the basics of the C++. Now we are going to have the structure of a C++ program. That is how we have to write the C++ program, that we will see. Hope you are writing down. Okay. Now write down the side heading as structure of C++ program. Structure of a C++ program. What is the format? General syntax. A very important question for 5 marks. Very important question. Most common question we say, no? Such a question it is. Explain the structure of a C++ program with a programming example. That will be the question. Clear? Yes. Now we will write the structure. Take it down, okay, parallelly. Structure of the C++ program is, it gives the general format of the program. First is the documentation section. First is the documentation section. Documentation section. Step by step we have to write. Okay, one after the other. We should not miss this order. First comes the documentation section. Okay. Next comes linker section. L-I-N-K-E-R. Linker it is. Linker section. Linker section. Clear? Next is the definition section. Definition section. Definition section. After the definition section, we have global variable declaration section. Global variable declaration section. Global variable declaration section. Clear? Then we have void main. We have void main, open and close parenthesis. Parenthesis means round bracket, open and close. Okay. Now you see this B is there now. This should be written with the lower case, because void is a keyword. Void is a keyword, and we know that all the keywords should be written with the lower case only. So void main. After the void main, open flag bracket. After the void main, open flag bracket. When you open the flag bracket, we will write local variable declaration section. Local variable declaration section. Okay. After the local variable declaration section, executable statements. Executable statements. Executable statements. After the executable statements, close the flag bracket. After the executable statements, close the flag bracket. After closing the flag bracket, so I will continue there, okay? Space is not sufficient, so I will continue there. So below that is below the executable statement, close flag bracket. After close of the flag bracket, you have to write this. Clear? There comes subroutine section. Subroutine section. Subroutine section. Then F1 open and close parenthesis, F2 open and close parenthesis, put some dots, Fn open and close parenthesis. So this is the structure of a C++ program. Very important question. 1 mark is allotted for writing this general format. The first is the documentation section. Write it down, because I will write a program, and in that program I am going to explain you which is that particular section. That is why write it down, because I will clear it now, so that you can compare with what you have written. First is the documentation section. Second is the linker section. Third is the definition section. Fourth is the global variable declaration section. Next comes void main. There we had discussed the void. When the function is not going to return anything back, void should be written, that void. Okay? Void main. After the void main, open flag bracket. Local variable declaration section, executable statements, close the flag bracket or the brace. Then subroutine section, F1, F2, etc. In this syntax, I will tell you this definition section is there, no? Definition section, this is optional. This Definition section is optional. What is the meaning of that? If you want, you can use it, otherwise no need. Depends on the requirement of the program. Clear? So this one is optional. Similarly, documentation section is there now. This is also optional. Documentation section is also optional. Okay. Then this global variable declaration section is there no? Global variable declaration section. That one is also optional. This is also optional. And this subroutine section is there no? Subroutine section, this is also optional. The subroutine section is also optional. Other than this, all other sections, they are mandatory or compulsory. So this is the structure of a C++ program. Just this is for your reference, you write it as optional if you want, then only. When the question comes in the exam, don't write optional and all. This is why I have written is, this is for your reference. That is, other than these four, all other things are compulsory. Clear? Only for that purpose I have written them as optional. Okay? Yes. Now I am going to explain you this one first program. So documentation section. I'll clear this, then one by one. Documentation section. Documentation section means you have to document your program. In the documentation section, you have to document your program. What do you mean by documenting the program? Documenting the program means documenting the program. You have to document the program. Documenting the program is nothing but writing comment lines. Writing comment lines. It is called as the documentation. What do you mean by writing the comment line? Is you have to write the title of the program. Why you have to write the title of the program? Others also, if they want to go through your program, when they look at your program, they should come to know which program it is. That is why we have to document it, or we have to write the comment lines. I have told you this is one optional section. So how to write the documentation is, there are two ways for writing the documentation. Okay, single line documentation is also there, multiple line also there. How to write is, you have to put a slash. This is the first method. Okay, you have to put a slash. You have to write the asterisk mark. Asterisk means the star mark. Clear? So then you write C++ program to find sum of two numbers. If you have to write, you can write like this: C++ program to find sum of two numbers. First slash, then asterisk. Then you write the statement that you have to write. After writing this, you have to close it. How to close it is, put the star mark and then again this one. Again the slash. When you write this documentation section, the C++ compiler as it is display this. That means this part will not be compiled. Means if this statement, this whatever you have written with the slash asterisk slash, it will not be compiled. Errors, spellings, any mistakes will not be detected. As it is printed or displayed. So this is the documentation. Like this also you can write. If it contains more than one line, you can write in one line this one, continue in the next line, then in the second line or third line also you can write the star and the slash. Clear? Then this is the first method. The second method of writing the documentation is single line documentation. This is multiple lines, more than one line also can be there. Single line documentation means 2 slashes you have to write. If it is a small comment, in that case you have to write it as 2 slashes. 2 slashes you write, and whatever you have to write, you write like this. Okay? This is the documentation section. What is the use or advantage of writing the documentation or comment is, others also, if anybody looks into your program, they will come to know about the program. That is what this program is about what you have written the program. That they will understand it more clearly. For that reason, if you write the documentation section, your program will become quite good. Okay? So this is the documentation section. Next is the linker section. Next is the linker section. What do you mean by linker section? Is when you write a program, the C++ compiler has to include some header files which are there in the standard library of C++. Okay, so to include the header files. In the other class you have written programs. Probably just one example program you have written in the other class. So there you have written this one. The linker section, it always begins with the hash. Okay? The linker section, it always begins with hash. After the hash, we will write include. Hash include. You should not leave any space in between hash and include. Here I have left little space. That is only for clarity I have left. No space between hash and include. Hash include. After hash include, we have to write this symbol. The less than symbol is there no on the keyboard. That symbol we have to write. Okay. So this symbol. Then we have to write the name of that particular header files. For example, the first and foremost and very important header file that we want is the IO stream.h. Hash include IO stream.h. This is the way of writing the linker section. One more is hash include. Then again the angle bracket con io.h. Con io.h. Again hash include io manip manip dot h. One more hash include math dot h. So these are some of the header files that are used, that can be included in your program by the linker section. When you write hash include, that tells the compiler that the user is including the particular header file. Okay? Hash include tells the compiler that the user wants to include these header files. Why you have to write this one? Because if you do not write this one, these header files will not be brought to your program from the standard library of C++. They will be present in the C++ library. But to use that header files in your program, you have to write this statement. Hash include iostream.h. What do you mean by iostream.h? Is iostream. I for input, O for output. Input, output, stream. Dot h. H means header file. So, input, output, stream, header file. What is the meaning of this is, it will get the functions that are important, that are needed for the input and output operations. Clear? The functions that are needed for input and output operations are present in the iostream.h header file. Okay? That is why you have to include this. conio.h. Conio.h means console input output. Console input. I for con means console. I means input output. Some of the functions are there which are there in this one. For example, when I write the program, I will more clearly I can explain this. But now you consider that the functions that comes under conio.h are, first one, very important one, one is CLR-SCR we will write. CLR-SCR we will write. This means clear screen. Okay? This means clear screen. Then second one is, one function is there which we call it as getch. Getch. Okay? So this function, it is used to get the output. These functions are present in the header file conio.h. Console input output. Clear? Next is iomanip.h. iomanip.h means input output manipulation. Okay? iomanip.h means input output manipulation. Input output manipulations. So the different functions that comes under iomanip.h header file are, important one are setw. This function, it is called as set width. This function is called as set width. Okay? Then the second one is end we call it as end. So this is for the end of the line. Clear? So this is about the iomanip.h. Math.h, this one you know, I have told you, that is other than the basic mathematical functions, that is addition, multiplication, subtraction, division, modulo division. Other than these 5 functions, for all other functions, we have to use the math.h header file. So for mathematical functions. So this is about the linker section. So linker section, it is the section which is used to include the header files in our program. Once we include the header files in the program, then only the compiler will come to know user wants to use which functions. then those functions will be brought from the standard library. These are some of the examples. Many are there. For each functions we have different header files. Most commonly we use them. Okay. So this is about the linker section. Next is the definition section. Definition section. Yes. What is the definition section? Is if you have to write or if you have to represent constants, then expressions, etc., then you can define them. You can define those things or define them by using the definition section. For example, hash, how to write it is, first we have to write hash. Okay, we have to write hash. After writing the hash, we have to write define, because we cannot write include. Why? Because include means it should always present in the library. Then only we can include it. Define means what? It is not present in the library. We are going to define our constants. Got it? For that reason we have to write the definition section. I have told you this is also optional. Okay. So hash, then you have to write define. Hash, define. For example, you know the value of pi. Pi is 3.142. Okay. Because the compiler cannot understand if you write pi. It doesn't know what is pi. You have to tell what is pi. That means you have to define the value of the pi. How? Hash, define, leave one space. Then you write pi. Spelling of pi is left to you. Pi you want, right? If you want pi also you can write. Because C++ compiler anyway it doesn't know what is pi. It knows the value that you are going to give for pi. Only about that it matters. Clear? So hash, define, pi, leave one space, 3.142. The value you have to write. Be very cautious while writing. Hash, define, no space. After that leave one space. Pi you write. After pi you leave one space. You should not write equal to. Not like this. This is wrong. Clear? Not like this. You have to write hash, define, one space, pi, one space, 3.142. Then the value of pi you can directly use as pi. Okay? This is an optional one. This is called as the definition section. Next comes is the global variable declaration section. Next comes global variable declaration. Global variable declaration section. What do you mean by the global variable declaration section is you can define or declare the variables. You can declare the variables globally. Globally. What do you mean by globally? What do you mean by globally? Is before any other function. Before any other function or before main or void main. Before main or before void main. Such a function is called as global variables. Such variables are called as global variables. And the life or scope. Life or scope. What do you mean by life or scope? Is nothing but the availability. That is, for which part of the program these global variables are available. It is called as life or scope of those variables. The life or scope or availability of the global variables is for entire program. Entire program. The life or availability of the global variables is for entire program. Throughout the program, whatever may be the size of the program that you have written. Okay, it may be 1 page, it may be 2 page, it may be 100 pages. So, for the entire program, the global variables are available. This is also the optional one. When we use the subroutine section, one section we have written now. When we use that subroutine section, then only we will use the global variable declaration section. Okay, so the global variable declaration, the variables are defined before any other functions or before the void main also we can write. They will be declared globally. That means the life or scope of such variables is for the entire program. Okay? Hope till here it is clear. In the next class, I will continue the explanation of this structure of the C++ program, and then we will write the programs. Hope it is clear. We will continue in the next class. Thank you.